All right, we're going to add a few terms to this. Vocabulary is going to be really important for this next couple of weeks because of all the different terms. A lot of the terms, you are familiar with what they mean. You just may not have used the term before. So the first thing that I want to add here underneath standard, write preserve. Does anybody know what the term preserve means? Many of you guys have ever had like strawberry preserves? What is preserve?
Don't change, keep the same.
Don't change, keep the same. It keeps it the same, right? Preserve is another way, if you wanted, some people like to think of it as the term equal. Preserve means that it stays the same. Nothing changes. So what I would do is I would put in parentheses next to it the word same. It's just another way to say that it keeps it the same. Okay? So congruent, the symbol for congruent, we've talked about this in the past, looks like an equal sign with that squiggle on top. Does anybody remember what congruent means?
Same size, same shape, something like that.
Very good. Same size, same shape. Everything stays the same. Similar is just this mark. That's the symbol for similar. Okay, which means it's going to be a little bit different than congruent. It's similar to congruent, but it's not the exact same thing. Similar means that it's the same shape. But what's different about it, possibly? Possibly a different size. Everything that is congruent is similar, but not everything that's similar is congruent. Okay, parallel, the symbol for parallel usually shows two lines that are next to each other, exact same slope. Parallel lines never touch. They never intersect. In other words, they have the same slope. Okay. Prime, we're not talking about prime numbers. We're talking about prime for geometry. Prime means that we've done a transformation, so it's the new shape. And it's after a transformation has been done. So after a translation, reflection, rotation, or dilation. Okay. A translation means that we're moving it left, right, up, or down. So it's just a slide. Whenever you do a translation, all of the angles are congruent. It means they stay the same. All the sides are congruent, which means they stay the same. And all parallel sides stay parallel. Now, are there any parallel sides on this triangle? No, there are no parallel sides, but if they were, they would stay that way. Okay, so translations are congruent. They're going to stay the same. All right, for rotations, it's pretty much the same thing again. Rotation means that you were going to turn it. We're turning the shape. Angles all stay congruent. They stay the same. All sides are congruent. They stay the same. And if we had parallel sides, those parallel sides would also stay parallel. So rotations are congruent as well. Okay. A reflection we think of as a flip, like we're flipping it over. So if we were to reflect this, it would still be that same shape, but it would be flipped over itself. So this would be B, this would be C, this would be A, and this would be D. And actually we would put prime there to show that it was changed once. But everything for a reflection stays congruent. So these three terms, translation, rotation, reflection, they're all what we would say are congruent. They all preserve the angles and their sides. Dilation is a little different. A dilation makes it bigger or smaller. So we would just take that same shape. Let's say we took it and we made it smaller. Or we could increase its size and make it much larger. But the angles stay the same. Okay, so the angles are congruent. But what happens to the side lengths? Well, the side length AD is smaller than, AD prime is smaller than AD, right? Okay, so the sides are no longer going to be congruent. The sides are going to be what changes. It's going to be different. Okay, and so since this one's different, make a big star or some type of symbol to catch your attention. That's something that you need to pay attention to. Because that one's not going to be congruent. Okay, parallel sides though, they remain parallel. So they stay parallel. Okay, so if dilations are not congruent, well, what's the other term we can use? Yeah, so dilations are similar, but not congruent. Okay, now, this bottom portion, PQRS has a transformation and results in KLMN. All right, so all they're saying is that we changed it somehow, and we just renamed it KLMN. Order matters. P is in the same spot as K, so P is congruent to K. So what does that mean R is congruent to? Q is congruent to, and S is congruent to. Okay, and that's going to be true at any point. Order does matter. All right, a transformation occurred to produce a shape that is congruent. What transformation did not happen? If everything's congruent, then which transformation did not happen?
Dilation.
Very good. Okay, there are a few things that I want to talk about on the back of these notes, so turn it over on the back real quick. Okay, we have the term image, and we have the term pre-image. Okay, image is what the shape is after a transformation. It's a lot like prime. Pre-image means that it's the original shape. Okay, so let's draw a rectangle ABCD. And let's say we move it right and we move it down and it stayed the same, ABCD. Okay, which one is the pre-image? The first one or the second one? Yeah, the first one is the pre-image. The second one is what we would call the image. Okay, now if they did not tell us specifically this is the pre-image or this is the image, then we would have to use our symbols for prime. So this, if I show you A, B, C, D, and then A prime, B prime, C prime, D prime, this symbol indicates that it is what happened after the original. So that's how you would tell also. Okay. If I give you a triangle ABC, okay, the symbol triangle ABC means the same thing. We've just named it, and now this symbol means it's a triangle, and these are the 3 points. Is congruent to triangle QRS. Okay, so now what if I were talking about the angles? The measure of angle A is congruent to what angle on the other one? A is the same as Q. How do you know? Order matters. So A came first, Q came first, so they must be corresponding. So that means that the measure of angle B has to be congruent to what? R. The same thing is true if I talk about side lengths. So if I say side length AB, what is congruent to side length AB? QR, because it's the first and second letter, right? Same thing if I say the angle CAB is congruent to angle what? SQR, because we just mimic the same order, right? Okay, and so those are some of the pieces of information that you needed to be introduced to.